Hi, my name is Ram Krishna Sharma, and I'd like to go over a Dijkstra traversal with you, which will illustrate the way in which, if we have a weighted graph, how we can actually find the shortest path from the source node to every other node in the graph in O of E log V time. Now, there are certain lanes here that the class I'm in, at least, has delineated, specifically between the node that we're concerned about, a node that is considered known, the distance from the source, which of course will gradually improve over time, not all the time, but there are instances within which it might make sense to update that distance if one is found. And then of course, the path. It's one hop back from it basically will record the parent through which that shortest path makes sense. Now, really the first step is to start with the source. In this case, that's V0. And the distance from the source to itself is, of course, 0. In that sense, we put 0 under distance, and we mark it as known. In other words, we know for sure the distance from the source to that particular node, which in this case is itself, with absolute certainty. That will not change. The path, of course, is null in a sense, because what does it mean to originate from yourself? Not much. And then we want to begin by looking at, this is of course part of the algorithm, by looking at all the nodes that emanate from the node that we're on. As you can see, we have V3, we have V2, and that is about it. And so what we do is we take the shorter of the two. Between V3 and V2, we will obviously say, well, we'll record not necessarily the shorter of the two, but we record the distances that we see for these neighbors. So in V3's case, it's distance 1 from the source, right? In V2's case, it's distance 2 from the source. And we understand that both of these emanate from the parent, V0. Now, this is kind of the pre-processing that had to take place in order to get us into the real meat of the algorithm, which is really just a two-step process, right? After you've kind of done this, after you've started from the source, labeled it as known, labeled its distance from itself as 0, which of course it is 0, you looked at its neighbors, you recorded their distances, you recorded the path from which they emanate, you are now left with the meat of the algorithm, which is a two-step process, once you've gotten this far at least. Take the next unknown node with shortest distance. Now, you have to recognize that these are actually the unknown nodes here. Don't really look at anything that does not have yet a distance. These are the unknown nodes, and so you ask yourself, well, let me take the next unknown node with shortest distance. As soon as you identify that, you mark it as known. So in this case, between V2 and V3, which are of course recorded here, we have an understanding that the next unknown node of shortest distance is V3. So we mark V3 as known. Now, right now, you're processing V3. When we said take the next unknown node of shortest distance, we are looking for the next node to process. We've recorded its distance from the source, and now we're processing it. We're in a sense doing the same thing we did on the source, which is to look at all of the neighbors that emanate from it. And so that is the core algorithm that repeats. Once you're done processing a node, mark the next unknown node of shortest distance as known. Look at its neighbors. That's the first part. So the next unknown node, in this case, we said was V3. We marked it as known. We know its distance from the source. Everything's fine. We're moving on at this point. And so, we can mark it as known because we're never really making the evaluation of what the shortest distance is from source to V3. Again, we only really ever do it once. And in that sense, we know for sure that there's no shorter distance from the source to that node. And you'll see this process repeat. So now we're on V3, we're processing V3, and we say, what's the next we say, well, look at all its neighbors, things that emanate from it, and record their distances from the source. So in V3's case, we see that it goes to V6, we see it goes to V5, we see it goes to V4. And we ask ourselves, okay, well, let's record their distances. For V5, that distance is 7, right? So we'll say V5, distance 7 through V3. For V6, we say the distance is 6 through V3. And for V4, we say the distance is 2 through V3. Okay, so that's the algorithm. That's the algorithm. Again, we're in a space where we ask ourselves, okay, well, we found the unknown node of shortest distance, we marked that as known, we looked at all its neighbors, we judged their ways to reach them from the source, and we recorded those distances or updated them. So we either recorded them initially or we updated them. With that in mind, we now do the same thing again. We ask ourselves, well, what's the next unknown node of shortest distance? We're actually looking at our record here, and we're asking ourselves, well, what's the next unknown node of shortest distance? So V3 is already known, V0 is already known. At this point, V4, V5, and V6 are unknown, as is V2. What's the shortest distance? Well, it seems like we have a tiebreaker between V2 and V4. Let's arbitrarily choose by the conventional set moving forward as being the lesser of the two in terms of node count. So we'll say, fair enough, this is the one we're going for. So we marked it as known. We're at V2. Check its neighbors and record its distances from the source. So V2, we see, okay, well, from V0 to V3, sorry, V2, right? So we're checking its neighbors. Its neighbors are V3. And then you say, okay, well, while we're looking at V3, the way to get to V3 from the source through V2 is 3. But we already have a better distance, 1, which is, of course, expected since we said it was known. The other neighbor for V2 is V5. Distance from the source is 4. V5 currently records 7. We should update that. Through which does it come through? Not necessarily V3 anymore, but V2. So we dealt with V3, we dealt with V5. Those were the only two neighbors for V2. Fair enough, V2's done processing. Take the next unknown node, shortest distance. In this case, 2 and 4 and 6, and nothing yet for V1. Which is unusual, since when we were processing V3, V1 should have gotten a distance of 6. So I'll go ahead and record that. But nevertheless, take the next unknown node of shortest distance. That would certainly be V4. We look at V4 and we say, well, gee, there's a way to get to it, right? 2. And V4 currently records that distance. But anyways, that's the next unknown node of shortest distance. We add the check mark there. Say that's through V3. And then we're processing it now. We're looking at its neighbors. We say, well, here we have V1. The way to get to that is 3, right, through here. And there's another way to get through that. It's 6. So V1 should actually update to 1. Its parent is V4. And of course, that would be the new distance, and nothing else emanates from V4, so we're done processing V4. Then again, next unknown node of shortest distance, clearly that's V1. And at that point, because it is V1, we look at everything that emanates from V1, right? Here we see 0. Um, gee, what's the shortest distance that can take us from V0 to V0? Well, that's clearly 0. So that's kind of redundant. Uh, and of course, since we're processing V1, we want the check mark there. And that's said and done. There's nothing to do. Next unknown node of shortest distance between 4 and 6 is clearly V5. And here we find that to get to V5, you can either go this way through V2 and have 4, which, by the way, is what's recorded already. Or you could go here, say, okay, well, that's 1, that's 7, right? So that's clearly not better. And if that's the case, we'll just leave it as it is. But nevertheless, it is known since we were just processing it. V6, distance 6 from the source. Is there anything better here? Not really, right? Could go around like this. That's 14. We would much rather prefer 6. Um, uh, so now we look at its neighbors, right? So you have V4 here, 6. That's to get to V4, you could go and do 9, or you could do 2. We already know that as a known node. And so that essentially ends up being our answer.